Okay, page 8 of your textbook, interpretation of graphs. So in this final section of the chapter, you'll be required to analyze and interpret pre-drawn graphs using everything you've learned so far. So the drawings given will generally not be drawn to scale, they just draw graphs. Now, 1. Basic principles of graph interpretation, x-intercepts. You need to also use x-intercept, y-intercept. You know how to find them when you're drawing it. You also have to be able to see them on the sketch as well. That, this is an x-intercept, this is y-intercept, for example. If you're given this and say, okay, here's A, here's B. You need to understand, if they say find coordinates of A and B, you're finding the x-intercept. So these are the x-intercept. If they say here's C, this is the y-intercept. That means you just make x 0 and then you solve for x. Here you just make y 0 and then you solve for x, and then you're going to find the coordinates there. That is this and this. You also need to be able to see that. Point of intersection. So for point of intersection, again, they'll give you a graph, something like that. And then they'll give you another one, like a straight line. They'll say, okay, there. Find these 2 points where the 2 graphs touch. So if this one is f of x equals to 2x plus 1, then the parabola is something like g of x is equals to x squared minus 2, something like that, or any form. To find these 2 points, again, this works with any function, whether it's a parabola, a straight line, a exponential, hyperbola. To find the point of intersection where they meet, you just equate the 2 equations. So you say this is equal to this. So you just say 2x plus 1 is equal to x squared minus 2. Then you solve for x. That means you move them to one side, and then it's going to be a quadratic formula, and then you solve. That is this one. And then, next one, horizontal distance. So for horizontal distance, you just do the following. Let's say they gave you a Cartesian plane, both horizontal and vertical. So I'm going to just explain the two. So this is about the distance. So let's say you're given a Cartesian plane like this. They said here it's A. It doesn't need to be on the x-axis, but then it can be. So here's A, here's -2, here's 1. You see, you find the length from A to B. We call that the horizontal distance. To find that, you just say the one on the right, which is the 1, you say 1 minus the one on the left is -2. Then you're going to get that the length is 3. That's what they mean. Same thing with vertical. If you have a point, vertical and horizontal, you just mean the points are like aligning like that, or aligning like that. If they are not aligning, you can just use the distance formula. That is, if one is up here and the other one is down here. Like if you want to find this distance, you just use the distance formula. Even this two, you can use the distance formula. It'll still give you the same thing. But then this one's, they're just showing that it's possible to do it differently. So vertical, if you have AB, now the x's are zeros here. The y's, let's say here's 2, here's -3. Again, you just say 2 minus -3, you get 5. That's the distance for that. Average gradient, still the same thing as the gradient. You just need the 2 points. So with those things at the top, you also need to know how to find the equation, domain, range, turning point, asymptote, isosymmetry, minimum or maximum value. Minimum and maximum value, they just mean the turning points. So if you know the turning points, you have your minimum or maximum. So here you have your maximum, here you have your minimum. So you find the turning point, the x is the way it appears, the y is the value they want for the maximum and the minimum. Inequalities. So for inequalities, the following, they can ask you the following. They can say, give us the values of x for which f of x is greater than 0. What does that mean? They just say find a region where the graph is above the x-axis. For example, let's use that same graph. So if you have a graph like this, let's say it crosses on -1 and 3. So where is it above the x-axis? Remember, there's the x-axis, there's the y-axis. So the graph is above the x-axis here. We use a different color here. it's above the x-axis right here. Here it's below. Below. Up until there, it's above. Above. So where is it above? It's above from this -1 going that way. That is less than -1. That way. Here it's going to be below. You see here it's below. Here it's above. So x is less than -1. Also x is bigger than 3. If they said equals to, that means you also just say equals to. So in the same case, this one, the second one, f of x less than, that means where it's below. So in this case, it's the region from here up until there. That means x is between -1 and 3. Again, also if they said equals to, again, I'm here. Sorry if I'm just complicating things. I'm here. Again, the same question. If they ask you where is f of x less than, that's where it's below in this case. So it's below here. Below the x-axis here. So it's between -1 and 3. If they say equals to, you just also add equals to there. Next one. Now you have two graphs. It's not just the x-axis. It's graph of f and graph of g. Where is graph of f? Above. That means above g. So f above g. So again, you'll have two graphs in this case. There's an example, but I'm going to use that. You can go there and use it, then check it. I'm just going to explain using mine. So let's say you have two curves. Let's use the parabola again. So you have a parabola that is here, it's -1, here it's 3. And then you have a straight line like that. Let's say here it's 4. So where's f? Let's say f is the parabola and then g is the straight line. Where's f above g? So you just compare the two lines. You check where's the other one above the other one. So we want where f is above g. So let's start here. When you're here, g is below, f is above. As you can see, f will be up here when you're here. When you're here, it's still f above, g below. That's what you want. When you're here, f above, g below. F above, g below. Up until here. So we know from x less than -1, f will be above. And then g will be below. Let's continue. When you're here, no, here doesn't work because f is below. We want f above. So f is below here, doesn't work. Below. That means below this line. Below. Here, f is above now. So it works here. So because f is going to continue going up, so it's going to be above. It's always above here. You can see it's above g. So also when you get here, so that means the answer will be x is less than 1, also greater than 4. So you just find that region where that happens. This one, you do the opposite, where f is now below. So this one is f below. This one is f above. So next one is this one. The last one that I'm going to do. These two, like how we did this one, you just compare the signs at that point. So like before, again, the parabola there, passes there. Let's see -1 here, let's see 3 here, let's see 4 there. So you compare the points, you start there. So you start here. When you're here, check the signs of the y's. Let's say this is f, this is g. When you're here, f is up here. So f is positive. So f is positive. When you're here, g is negative. So here, we want greater than 0 means positive. This one doesn't work. So when you're here, it doesn't work. Because positive times negative, it's going to be negative. We want positive. That means both signs, it's either you have positive, or negative. That's what we want. So let's check those reasons. So when you're here it's negative, here it's positive. Positive, negative, 0, 0. Here it's positive, negative. So it still doesn't work here. Positive. Positive because we're above this. The y's are positives. positive, positive. Then here, negative, 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 negative. After here, positive. So after here to x, because now it's positives. So everything is positive. That means here it's going to be positive times positive. That's going to give you positive. That means it's going to work. The answer will be x bigger than 3. Because when you're here, it's going to be positive times negative. Positive times negative. Positive, it doesn't work. The x when they're the same. So it's after here in this case. And you can apply this with all the other graphs as well. Similar to this one wants them to be not the same. That means one has to be positive, one has to be negative, because the answer says less than 0. Less than 0 means negative. So that means that in this case, it's going to be here, it's going to work, here it's going to work, here it's going to work. Not working because it's less than 0. Here it's going to be 0. So it's going to work, it's going to work, it's going to work, it's going to work. So it's going to be x is less than negative 1. X is also between negative 1 and the number that's here, 3. So in this case, it will be those answers. You can apply it on the example and see the other ones, but then the general thing is basically what I just did here. Try to apply it on other things, even the length and so on. Just need coordinates. Just check it out. I'll stop there for now.